We're told that electric cars are the future. Petrol and diesel cars are to be banned in the UK by 2030, and many European countries and American states are following suit. But although performance improves tenfold, skeptics still have their reservations about promised electric vehicle range. Some diesel models today claim beyond 700 miles on one tank, some models up to 1,000. And although very few people will ever have the discomfort of driving that far in one trip, electric vehicle range is still a topic that needs addressing in order to entice more people to reduce their local emissions. Right now, EVs average somewhere around 300 miles from one charge, a huge leap forward from the barely triple figures of the past, but a far cry from the modern-day diesels that can achieve more than double this, previously popular among environmentalists for its high MPG and low carbon emissions, despite higher nitrous oxides coming from the tailpipe compared to petrol engines. Samsung's Advanced Institute of Technology claims that a new chemical breakthrough means that it can achieve double the range compared to current offerings. The secret lies in the electrolyte within the cells. Whereas conventional batteries use a liquid electrolyte or sometimes a polymer gel, these latest technologies remove the liquid from the equation and replace it with a solid electrolyte. This can include ceramics, glass, sulfites, or solid polymers rather than gels. Lithium-ion batteries rely on an electrolyte which separates a cathode and an anode, through which charged ions travel. Samsung's scientists have developed this solid alternative which results in a far denser approach than previously used liquids. It creates a more controlled and compact layout which brings the added benefit of preventing the growth of dendrites, needle-like structures that adversely affect battery capacity over a lifetime. A new silver carbon coating with a chemical composition of AgC measures just 5 micrometers thick, thus reducing space and weight. It can therefore improve efficiency and add those sought-over additional miles to the specification of the vehicle. A battery pack measuring the same size can instantly double the expected range for an electric vehicle, or similarly, to achieve the same range, a battery pack just half the size would be required. This is perfect to fit both small city cars as well as family cars that require the added benefit of range extension. The company promises 2 to 10 times the energy density of other lithium-ion batteries, without compromising on power. All of this helps achieve a 1,000 cycle life, which could result in more than 500,000 miles. As ever, it's not just what the consumer sees, but what the consumer doesn't see that's more important. Of course, extra range is appreciated, even desired by most of us. But by removing the liquid aspect, engineers have managed to find a way to reduce the rare, but real and feared danger of batteries. No, we don't all drive like Richard Hammond, but with so many cars on our roads, accidents can and will happen, and having a car that's less flammable is always a bonus. Additionally, and similarly, in line with fire hazards, the exothermic reactions that happen inside a battery generate lots of heat. And as things heat up, they also expand. The possibility of a ruptured battery comes with a whole host of risks, but this is partly eliminated with solid-state batteries. Better thermal efficiency even means less cooling and controlling components are needed too. Project leader Dongmin Im said, "The product of this study could be a seed technology for safer, high-performance batteries of the future." Going forward, we will continue to develop and refine all solid-state battery materials and manufacturing technologies to help take EV battery innovation to the next level. In fact, Bentley sees this sort of technology as the real game changer. The company expects that solid-state batteries will power its range of electric vehicles, helping to deliver a suitably premium offering. Parent company Volkswagen doesn't see this type of technology being offered in its batteries for a decade or so, but other automakers wish to challenge this. An all-Japanese consortium has been established by automakers Toyota, Honda and Nissan under the name Libtech, with the primary goal of realizing the production of solid-state batteries. Volkswagen is not alone though. Panasonic, one of the most important battery manufacturers in the world, agrees that a decade is a reasonable time frame to expect to see solid-state batteries in our electric vehicles. This is coming from the company that produces Tesla's batteries, the company that is currently working on providing Tesla with the next generation of tabless cells on a shorter scale of 3 or so years. Quantum computing could let us effectively peer inside the battery's chemical reactions to better understand the materials and reactions that will give the world those better batteries, says Katie Pizzolato, Director of Applications Research at IBM. This will help formulate the best plan of action for solid-state development in the future. Tech giant IBM is working hand-in-hand with Daimler, parent company of Mercedes and Smart, 2 brands with an existing inventory of electric offerings. Another world leader in battery-powered devices is Dyson. famed for its vacuum cleaners and more recently its offering of fans and hair products. You'd be forgiven for thinking that Dyson is ahead of all competition when it comes to consumer electronics. The company had previously announced plans to build its own electric car, destined for a 2021 launch, but plans for this were scrapped last autumn. The company still promises to be working on advancing battery technology, but so far the car project has been pushed back, if not entirely cancelled. So far, we've explored the benefits of solid-state batteries, but we are yet to encounter any drawbacks, of which there are seemingly very few to none. We can't even report that cost would be an issue, because although expensive to develop, it is expected that they will be cheaper to manufacture en masse to current lithium-ion batteries. Yes, development will likely set back companies millions of dollars, but is that not the same about any new technology? Right now, they prove to be harder to manufacture on scale, and there's still a lot of work to be done to get solid-state technology ready for the mass market, but the concept is in its infancy. We're talking months, not even years. Companies are yet to pinpoint the exact atomic and chemical composition of a solid electrode for maximum efficiency, which also has the right ionic conductivity to provide the car's electric motor with sufficient power. Getting the electrolyte right is vital and sets up the rest of the journey to allow the use of lithium anodes, which would produce more lithium ions. This means one thing: more ions, more energy. This can be translated into the extended range that we're promised. Although destined for use in road-going electric vehicles, this young technology has still not debuted in even consumer gadgets. We're still using what will become the old type of battery in our latest smartphone, laptop, and smartwatch. This may change with the new technology, though. In summary then, solid-state batteries replace the liquid found in conventional lithium-ion batteries with a new solid type of electrode, which brings with it an increased energy density, helping to power up to double the range of current models, as well as lower internal resistance, corrosion and wear, allowing for faster charging to occur. No leakage happens within, which reduces energy wastage, while the risk of flammability is almost cut to zero. Hand in hand with the extended range is the equally important longer lifespan. Solid-state batteries are expected to have a real-world lifespan of up to 10 years compared with the 2 years that we tend to see battery degradation begin to occur. So far, we're unable to identify any crucial drawbacks. However, as mentioned, work is still being carried out on securing the correct solid material that best suits the job. This will be the point at which we're likely to see solid-state batteries really talked about in the media. Current indications suggest that we might see them implemented in cars we drive by the end of the decade, but that's owing to successful testing and probably an improved economic situation over this year. Which aspect are you most excited for in solid-state batteries? Is it the improved safety or the extended range? Will it be enough of a showstopper to divert attention from Tesla's spotlight when it launches the new tablet design in the nearer future?